again, and welcome back to another edition of Awesome Algebra 2 with Miss Faust. Today we are going to look at how we can take the next step and actually solve rational equations. So if you remember the very first problem we did in this unit when we talked about Justin and his t-shirt business, you might remember at the end we were trying to figure out when Justin would, or how many shirts he would need to sell in order to break even at $17.50. So the equation that we set up was something like this, where 200 over x, because it was $200 for his kit, divided by x shirts, plus 10, because he was paying $10 per shirt. We're trying to figure out when that was equal to $17.50. So this is an example of a rational equation. And by the end of this lesson, you will know how to solve something like that. So that was just to take you back and put it in context. You're looking for Justin's magic number there. Obviously, you guys did it some other ways. We did it with a graph, but we're going to look today at how we solve it algebraically. So the steps for solving, and I'm just going to write these out, and then we'll go through examples so you'll see what they mean. Your first step is to always find the least common denominator of the whole equation. So you look at all the parts of it, and you find the least common denominator. In this equation, the only denominator is x, so the least common denominator would just be x. Sometimes you have to factor to find it, so any other steps that come before finding least common denominator, so like factoring, I'll put in parentheses, because we always do that first, and we find the least common denominator. Then we multiply all parts of the equation by that LCD. And the difference here is in addition, we multiply on top and bottom. Here we only multiply once, and you'll see why. It makes a bunch of things cancel, and it gets rid of our fractions. So the next thing we do is we cancel common terms. And then we're left with an equation that we know how to solve. So we solve the remaining equation. And sometimes that will be a quadratic. If it's quadratic, we can either factor it again or we can use a quadratic formula. If it's linear, we use inverse operations, but you'll see all that as we go through. So those are our steps. Example 1, let's just dive right in. So in example 1, we are going to start with, sorry, that's a little bit crooked. There we go. Where was my example 1? 9 over 4x minus 5 over 6 equals negative 13 over 12x. So what we want to think about here first is we want to think about what those factor into and what our LCD will be. So if I look at that first one, I see that 4x is really 4 times x. 6 I could break down more if I needed to into 2 times 3. So this could be, let's see, that could be a 2 times 3. And then my 12, I'm going to break that down into 4 times 3 because then I'll have some of these common factors from here. So I'm going to make that 4 times 3 times x. It's going to make my life a little bit easier than when I get my least common denominator. I could have also made it 6 times 2, but then I would have had to deal with this 4 again. So for right now, we're going to call the LCD 4 times x times 2 times 3. And notice then I've gotten all those taken care of. I've got the 4, the x, the 2, the 3, the 4, the 3, and the x are already there. So what I do now, I'm going to write my same problem again, and let me write it in black again so you can see. 5 over 6. I'm leaving a little space, and you'll see why in a second. So those are all from my original problem. And what I'm going to do is I'm going to take this least common denominator and I'm going to multiply each part by that whole thing. So I'm going to put 4 times x times 2 times 3 in front of that. I'm going to put 4 times x times 2 times 3 in front of that. And I'm going to put 4 times x times 2 times 3 in front of that. Okay, so I've just taken that LCD and I multiplied each part of my original problem by the LCD. Now I go through and I cancel common terms. So I look at this now. I look at each part separately and I cancel the common terms. So in this first part, I have a 4 on the bottom, which I'll cancel with that 4 on the top. I have an x on the bottom, which cancels with the x on top. That's all I can cancel. I've gotten rid of that denominator. Here I have a 6. Well, the 6 will cancel with this 2 times 3, because 2 times 3 is equal to 6. Gotten rid of my denominator again. Over here, 4 times x times 2 times 3. Well, for 12, I need the 4 and the 3, because 4 times 3 is 12. And then the x also cancels. So what that leaves me with then is 2 times 3 times 9 minus 4 times x times 5 equals 2 times negative 13. Well, that still looks pretty complicated because I got to do that multiplication. 9 times 3 is 27. 27 times 2 would be 54. So 54 minus 20x equals 2 times negative 13 is negative 26. So I'm just going to come up here and continue going. 54 minus 20x equals negative 26. So we move that. It doesn't matter what I move where, actually. I just need to move stuff from one side to the other. I'll add 20x on both sides, and then I'll get 54 equals negative 26 plus 20x. Then I can add 26 on both sides, and then I'll get 54. That's all in the way, running out of room. 54, 60, 80 equals 20x. Divide both sides by 20, and you get x equals 4. So our final answer for that is x equals 4. We go back and plug that in. If we put all that in for all the x's, it would work. I know, you trust me. I don't actually have to prove it to you. The one other thing just to keep in mind is you always want to look at excluded values too. So if we go back to this, notice the only excluded value we have is that x cannot be 0. Well, if we had gotten a 0 here as our answer, then we'd cross that out because it's an excluded value. So when you solve the remaining equation, you always just check to make sure that your values aren't excluded values. Okay, so I'll just add that right up there. So moving on, let's do another example or two. So questions, notes, example 2. Example 2, we're going to have 3x plus 7 over x minus 5 equals 5x plus 17 over 2x minus 10. So here we have to go through and we have to find our least common denominator now. So what we want to do is we want to factor this part. When we factor that part, 2x minus 10 is really 2 times x minus 5. Well, that's kind of convenient because I already have an x minus 5 over there. So my least common denominator for this problem is going to be 2 times x minus 5. I don't need 2 copies of x minus 5. I just need 1. So now I take that 2 times x minus 5 and I multiply it in front of this and in front of this. Not on the top and bottom like we did with addition. We just put 1 copy of it. So 2 times x minus 5 times 3x plus 7 over x minus 5 equals 2 times x minus 5 times 5x plus 17 over, and I'm going to write the factored form because it's going to be easier for me to see what cancels that way. So I just used this factored form of that denominator when I wrote it out. Now I go through and cancel. So the x minus 5 on the bottom cancels with that x minus 5. That x minus 5 cancels with that x minus 5. And the 2's cancel on that side. So what we're left with is 2 times 3x plus 7 equals 5x plus 17. It's a linear equation. Do a little distribution over here. 6x plus 14 equals 5x plus 17. Move the numbers to one side and the x's to the other. 3. 1x equals 3. So the answer I get is x equals 3. I go back up here and I just check to make sure. I want to look at what my excluded values would be. So from that one, x can't equal 5. And from this one, it would also be not equal to 5, because when you divide 10 by 2, you get 5. So that's my only excluded value. That's not one of them, so this is my final answer. Okay, let's do one more example together, and then you guys will be good to go. So, last example, I'll just start a new page, because sometimes these take a lot of space, and I have to be super careful about how big I'm writing. And I don't like to stop in the middle and not be able to finish, etc., etc. Example 3, we have 5 over x squared minus 3x plus 2 minus 1 over x minus 2 equals x plus 6 over 3x minus 3. So we want to start by factoring. Thinking about all of these denominators. So I have x minus 2 there. Here I need two things that multiply to positive 2 and add to negative 3. So I'm just factoring this. I know I'm going to need x's first. Negative 2 times negative 1 is 2. Negative 2 plus negative 1 is negative 3. So that's x minus 1 and x minus 2. This one doesn't factor. Two pieces, no squares, no common terms. This one, I look closely, I have a 3 in both of those, so that factors into 3 times x minus 1. So those are all the factors of my denominators. So when I go to write my least common denominator, I write x minus 1, I write x minus 2. I don't write x minus 2 because I already have it. I have 3, I'm going to put that in front just because I think it looks neater if you put your numbers in front, and x minus 1, which I already have. So that's my least common denominator. Don't need to do anything more with that, except take it and multiply it by all three parts of my problem. 3x minus 1, x minus 2 times 5 over x minus 1, x minus 2 minus 3 times x minus 1 times x minus 2 times 1 over x minus 2, again just coming back up here, that's going there, equals, I'm going to run out of space, 3x minus 1 x minus 2 times, I'm going to squeeze it in, x plus 3, nope, x plus 6, just kidding, over 3 times x minus 1. Just got it in there. That's 3 times x minus 1 in case you can't see it. But right now I'm just going to go through and cancel. So I look at each part separately. So when I look at this first part, I stop at the minus sign and I see an x minus 1 and an x minus 2 on the top and the bottom. Those go away. Now I look at just this part. I see an x minus 2 on the bottom, so that's going to cancel with this x minus 2 on top. Then I look at the last part. I see a 3 and a 3. I see an x minus 1 and an x minus 1. So those are all my parts that cancel. I am left with 3 times 5 minus 3 times x minus 1 times 1. I don't need to put another times 1 in there because that's not going to change anything. Equals x minus 2 times x plus 6. Now I need to solve that equation. My fractions are gone. So because my fractions are gone, I can go through now and I can solve this equation. So if you look at the right-hand side, the x minus 2 times x plus 6, in order to simplify that, I have to use the box method. So I made the little box to multiply it out, and I got x squared plus 4x minus 12. If you want to pause and take a look at that for a minute longer, you can. So on the right side, I replace it with x squared plus 4x minus 12. On the left, I do 3 times 5 and get 15. And then I take this negative 3 and I distribute it through my parentheses. So negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. So now I have a quadratic, but I have a really complicated one. So what I'm going to do is I'm going to move all this stuff over here. So I have a 0 on one side. So to do that, I've got to subtract 15, which I put by my 12 because it goes with my whole numbers. I've got to add 3, which I put with my 3x, I'm sorry, which I put with my 4x. Then I got to subtract 3. So again, I put that with the negative 12. So when I combine everything on the left, I get a 0. And when I combine everything on the right, I get an x squared, I get a 7x, and I get a minus 30. At this point, you might think about using the quadratic formula, or you might look at this and you might say to yourself, do I know two things that multiply to negative 30 and add to 7? And when I think about that, I think of 10 and 3. So if I want that to be a positive 7 and a negative 30, I'm going to make it x plus 10 and x minus 3. This is a lot quicker to solve than a quadratic, because I know 0 is either x plus 10 or 0 is x minus 3. Well, that one gives me negative 10 for x. That one gives me 3 for x. I look back to the very beginning just to make sure those aren't excluded values. And again, the way I know that is from looking at these denominators. So my excluded values for this, x couldn't equal 1 or 2. Well, these are not 1 or 2, the negative 10 and the 3. So those are the two solutions for this problem. Okay, so if you have any questions, jot them down in the margins, and I will see you next time in class. Have a great day.